and gentlemen, I welcome you all to Shito's Mathematics Coaching Program. At the end of this video, I want every one of you to subscribe to my YouTube channel, and do not forget to hit that bell at the subscription button in order to get my notifications anytime I drop my videos. Today we are going to look at another aspect of quadratic equation. So today we are going to look at how is quadratic formula being derived, and we look at one of its applications. So how we can use quadratic formula to solve a problem in a problem of quadratic equation, because this quadratic equation is the general formula we can use to solve any kind of quadratic equation you might encounter. So today, the quadratic formula is the solution to general equation of quadratic. So now by considering the complete square method, so we try to solve the general equation of quadratic, then we get the value. So now let's say we have the equation of quadratic, that is ax squared plus bx plus c equals to 0. So this is the general equation of quadratic. So now we will now be considering the complete square method to solve this equation. So from the last video I dropped, so I showed us how we can derive or how we can solve quadratic equation by completing the square method. So I don't think this should be a problem here. So now the first thing we are going to look at is we try to make sure that the coefficient of x squared is unity, that is to be 1. So if you have anything there, so we try to do away with that. Definitely we are having here is not unity. So we try to divide through by a so that the coefficient of x squared will turn to 1. So to do that, dividing through by x squared, we have x squared plus b over a x plus c over a. So now 0 over a. So we actually give us what? We actually give us 0. So therefore, we still have what? We still have 0. So now from here, the next thing to do is to take your constant term to the other side, so that you'll be left with x squared plus b over a x. So now doing that, so we have x squared plus b over ax equals to minus c over a. That is the third step. So now after taking this to the right hand side, so the next thing to do is to make the left hand side of this equation the perfect square. So now how are you going to do that? That means we are going to take the half. We take the half of the coefficient of x, then we square it, then we now add to the both sides. So now doing that, we have the b over a is the coefficient of x here, multiplied by half, that is half of this. We have half of this square, we have b over 2a all squared. So now that is the half and square of what? Of the coefficient of x. So now to do that, what are you going to do? So we add the result to both sides of this equation. So we have x squared plus b over ax plus b over 2a all squared equals to minus c over a plus b over 2a all squared. Are you following me? Now after that, so now you can see that we've already made this left hand side be perfect square. So you now want to write this left hand side in form of factors. So let's try to write this one in form of factor. So we have what? We just take this one, we take this one, then we take this one, we take this one. We have what? We have x plus b over 2a all squared. This is the factor form of the left hand side. So it is equal to, So this one, you can try to write or to try to change the position of this. So it doesn't change anything. And you just only want to have a positive for a positive value to be the first. So you have b over 2a all squared minus c over a. Yes. So we didn't change anything. So it's still the same thing. It's still the same thing. So now from there, so what's the next thing to do here? The next thing to do is to solve this right hand side further. We have x plus b over 2a all squared equals to, we have b squared, that is b raised to power 2, b to power 2, and 2a to power 2 have 4a squared minus c over a. Now solving this one further, so we take the LCM of 4a squared and a, so we have what? We have 4a squared to be the LCM. So now if you want to do that now, so 4a squared in 4a squared, so we have 1. That 1 multiplied by its numerator, we have what? We have b squared minus 4a squared divided by a, so we have 4a. 4a multiplied by this, we have what? We have 4ac. So we have x plus b over 2a all squared. So now what's the next thing to do? We are looking for the value of a, what the possible value of a. But you can see that here, this x is enclosed by this bracket having the power 2. So now the first thing we are going to do is to find a way to do away with these 2. So now to do away with these 2, what are we going to do? So definitely we are taking the square root of both sides, because we want to do away, we want to get rid of this 2, which is the power. Then the only thing we can do is to take the square root of this. So now, so far you are taking the square root of the left hand side, definitely you'll be taking the square root of the right hand side. That is the law of equation. So now from there, so taking the square root of both sides, so this one will turn to, because this square root, the square root will what? We do away with this, we turn this one to 1. So we have x b over 2a equals to the square root for this side, b squared minus 4ac over 4a squared. So now from here, we try to write this one further. Don't forget that anytime you have square roots, so you always attach it with plus or minus, because we are going to get two possible values. One will be positive and the other will be what? Negative. So that's why we have plus or minus equals to b squared minus what? Minus 4ac over, look at this one, we have 4a squared. 4a squared, that is the denominator is a what? Is a perfect square. So and when you have a perfect square and the square root together, definitely something must be what? Something must be happened. So now what will happen here is that the square root of 4 here is what? Is 2. While the square root of a squared, that is a squared, so we have a. So we have a here. Are you get what I'm saying? Because this square we cancel this. So now we have x plus b over 2a. Now, okay, don't let us waste most of our time again. So now from here, we are looking for a. Definitely we try to do away with this also. Definitely you are sending this to the other side. So now sending this to the other side, we have x minus b, because you are sending it to the other side. Definitely the sign must be changed. So now the sign has changed to negative, that is minus. We have plus in the left hand side. So taking it to the right hand side, definitely the sign will be changing. Definitely you now be changing to what? Negative. That's why you have negative here. Plus or minus. Don't forget your plus or minus. B squared minus 4ac over 2a. So automatically this can be written in a simple fraction as what? Minus b, don't forget the square root, minus b plus or minus b squared minus what? 4ac over what? Over 2a. so far, the both fractions are having the same denominator, which is 2a. That's the reason why we need to write it in a single form of fraction like this. So this is the derivation, and this is what we call quadratic formula. This the required solution, and it is called quadratic formula. So it is called quadratic formula. So some students do call this almighty formula. So there's nothing like almighty formula. It's only God that is almighty. So there's nothing like almighty in this formula. So you either call it quadratic formula or you call it general method of solving quadratic equation. So that is how we derive this quadratic formula. So the quadratic formula is the simplest way to solve any problem on quadratic equations. So you don't have any problem. The only thing is to compare. If you are given any kind of equation, that is general equation of quadratic, just compare. If you are given any kind of particular problem to solve on quadratic, just compare the equation to general quadratic formula. Then you look for your a, b, and c. Then you substitute or you put the values of a, b, c into this formula, and you get the value of x directly. So that's what that's how we do now. So now, in order not to waste much of our time, so I'll try to give us one example to see how it is being applied, how we can use it, quadratic formula, to solve problems on any kind of equation you are given to solve. So now, so let's look at this. Let's look at this one. Let's say you are given this particular questions to solve. That is, solve x squared plus 3x minus 2 equals to 0. So now, saying this, is what it is called quadratic equation. Actually, it is particular. This is not general this time around. Understand? Because a, b, c are known, so we know them. We know our constant there. So it is particular. We call it particular equation for quadratic. So now why do we call it quadratic? Because the highest power of the variable here is what is 2. So that's why we call it quadratic equation now. So from here, so what's the next thing to do? The next thing to do is to compare this given equation to general quadratic formula in form of what? Compare this to what? To as squared plus bs plus c equals to 0. So this is actually what we call general quadratic formula, general quadratic equation. So don't be surprised we are seeing a, b, c there. So a, b, c, they are just what? They are just constants. So any form of letters can take the position of them here. But generally from the formula we've seen so far, so they use what? In some textbooks, so they use A, B, and C all through. Understand? If you like, you can use P, Q, and R for your constants. So now from here, so comparing this and this one to this one, so you have x squared here, x squared here. Therefore, we compare the coefficients of x squared. We compare the coefficient of x, then we compare the constant term from the two equations. So now from here, by mere looking, we can see that a is what? A here, you can see that a is 1. That is, the coefficient of the square is 1, and we can see that b is what? Is 3. The coefficient of what? The coefficient of x is what? Is 3. While the constant term, that is c, will be what? Minus 2. Don't forget, don't just put 2. It will be minus 2. So you can only put 2 when you have what? You have addition here. Understand? When you have addition here, you put 2. But by minus, that minus is very, very important. You need to take note of that. Because if you mistakenly jump this, I mean the minus, you not include the minus, definitely you arrive at the wrong answer. So that's the reason why your signs notation must be what must be well known to you. You need to be very very careful while you are doing mathematics that involve addition and subtraction. So you need to be calm down, calm down. So that's what we are going to do. So now from here, you have gotten the values of these constants a, b, and c. So now we now bring down r by quadratic quadratic formula. Our you bring down our what's it called? You bring down our quadratic formula. Actually, from the one we derived earlier, so we have x is equal to something. So let's say the equation given to us is not of term x, is of term y or term other variable you use. Understand? So now instead of you writing x equals to minus b and so on and so on and so forth, what you do is what you write that particular variable. So let's say we have y here. Instead of we having x equals to, we have y equals to. If it is p, you have p equals to. If it is anything, you have that equals to. It's not necessarily you must write that what you must write that x. The reason why we have x is from the general equation of quadratic. So the variable we have there is what is x. That's why we derive it to be x. So now if it is y we use, so we put what we put y. So now here, so we have x equals to minus b plus or minus b squared minus 4ac over 2a. That's what we derived earlier, which is quadratic formula. So what are you going to do? You substitute, you put all these values into this equation. So we have minus b, that is minus 3, plus or minus b squared is what is 3 squared, which is 9, minus 4 times a. A is 1 multiplied by minus 2 all over 2 times 1. So now from here, the next thing to do is to know how you add, how you subtract, and how you multiply numbers in mathematics. So now that one is what is not a problem here. So now how do we do? We have x to be equals to minus 3 plus or minus. This one will be 9. That is 3 to power 2 is what is 9. Minus 4 times 1 minus times minus 2, we have what we have plus 8 divided by 2. Automatically, we have what we have minus 3 plus or minus 17. 17 square root of 17 over 2. So now, you can also rewrite this, or we change the position of this. That is, let root 17 come first because it's the positive, what is the positive value, and let the minus 3 go back. So now, how are you going to do? You have x to be root 17, that is plus or minus root 17, plus or minus, or you give your answer like that, anyone you like, so that in order not to be confused, so you can leave your answer like that, that is minus 3 plus, you take the positive side, root 17 by 2, or minus 3, you take the negative, minus root what 17 over what by 2. So these are the two possible values of x of this what I mean the possible values of x are this, which are the solution to this given equation. So that is how we use. So here you can see that we don't have what's it called? We don't have a whole number to be our result. Yes, it happens like that. So if you see this kind of question like this, you lead to this. You can see our questions our values are in short form. So it is preferable you leave your value here in what values here in what in short form, so that there won't be anything like approximation. But if you are given to approximate to a particular number of decimal places, so you can do that. But if it is not specified from the question given to you, so I urge you to leave it like this, so that you have what you have your combined form of answer. So where it won't need of you approximating. I don't know. Are you getting what I'm saying? So now that is how it is being solved. So from here, you can use quadratic formula to solve any kind of equation. So because you can use it to get solution, okay, we call this value the root. Yes, the root of what, the root of quadratic equation. So if you look for the possible values of x of quadratic equation, we call them what, we call them roots. They have value, or we call them what, we call them roots. So at times we have natures of roots of a of equation, quadratic equation. So roots can be distinct at times. That is, the nature of one of a root can be distinct. That is, real and distinct. So we can have equal roots, and we can have what, we can have complex roots. But this type of the in this type of question, so our possible roots that we have, they are real and distinct. That's the nature of these roots, because they are different. They are different. But if they are equal, so we call them what, we call that equal root. Why? If it is what, if it is attached to, or we have it in form of ai plus b, understand? So this is what, this is complex value because of this imaginary number, understand, because of this I. So we'll be looking at that later when we are talking about complex numbers. So we are not dealing with complex, we are dealing with real number. That's why we have this. So that is the end of today's lecture. So once again, I urge everyone to make sure they subscribe to this my YouTube channel. Then you do not forget to hit that bell at the subscription button, so that you get my notification anytime I drop my video. And if you have any question to ask, don't hesitate to click on the comment box and ask any kind of your choice concerning what we have learned so far. So, and am promising you I will do the needful to return or to get back to you of your questions. So you have a beautiful day ahead of you. So I greet you once again. I remain myself, Shitu. We meet once again. We meet some other time. Rather, don't let me say once again. We meet some other time. So